So, as an example, okay, what they say is find the image of tree 2 under the translation that maps 5 2 onto 7 6. Now, the way you could do it is two ways. You could draw 5 2, and you could draw 7 6. 7 6 would be there, wouldn't it? 5 2, 7, and 6. Okay. Now, what's the rule to go from 5 2 to 7 6? Your start point to your end point. What's the general rule? We're going across 2, up 4. That means all what you have to do with this one is add 2 onto the x value to get 5, and add 4 onto the y value to get 6. Now what it looks like on the graph would be 3 across 2 up. That's your point there, yeah? The image is where you're sending it to. You're meant to send it across 2, up 4. And that's the image. And that's the point we predicted, wasn't it? 5 across and 6 up. It told me that the start and end point, it told me what to do. It told me to move it the same way. Move it 2 across, 4 up. So this point here was the point they gave me to move, and I moved it 2 across, 4 up like they asked me to. That make sense? Huh? Not really. Okay, slow down. So what we're doing next is this. We have another rule. The other rule is this. We have a general rule. So ignore these points for the time being. Just ignore this full bottom part. And what we have is find the image of each of the following points under the translation that maps -3 1, which is this point, this point here, and it goes to -5 4. Okay. Now, this is the start. This is the finish. We have to go across 2 and up. Yeah. So technically speaking, it's -2 because you're going left 2 and a positive 3. So the rule would be -2 to your x value and +3 to your y value. Now, we're at the point 6 2. 1 2 3 4 5 6 6 2. We have to move 6 2 in a similar fashion. We have to go 2 to the left and 3 up. So 2 left and 3 up, and that's our new point. Is that alright? The new point is 4 5. Now I could do it like this. Take 2 away from 6, 4. Add 3 onto 2, 5. Is that alright? Okay. You don't have to draw, you can do it in your head. But I'm just saying, like, it's great if you can sort of picture what you're doing though. In your head even. So look at this point now. -6 0. Where's -6 0 located? Well done, Cameron. Now, here. It has to go a similar direction to this one. So it's going to go up here somewhere, okay? So 2 across and -6 0. 2 across, 3 up. -8 3. If you want to do it in your head, take away 2 from -6 and you get -8. Add 3 onto 0, -8 3. Is that right? Excuse me. Now, what we have here is find the missing coordinates of each of the following parallelograms. Okay. So a parallelogram, we all understand, it's the same in any generic parallelogram. So if I was to draw a parallelogram here, and let's say I want this to match up nicely, something like that. Okay. You notice that from this point to this point, it's 1 across and 5 up. From this point to this point, it's the same rule. 1 across and 5 up, because they're parallel to each other. You have to undergo the same rule. Likewise, it's 4 blocks across to go from here to here. That's 4 blocks across to go from here to here. So what you're going to do is you're going to be given you're going to be given some points on the parallelogram. So as an example, part 2. -2, -1. Now I struggle to do these in my head. I'll always draw. So and then 2, -2. I don't know where the other one is. And S is 2, 3. Now, there's one thing I also need you to remember is that the letters are actually significant. So, as an example, see the way it says PQRS? That means P is linked to Q, Q is linked to R, and R is linked to S. You're only not linked if there's a letter in between us. You're not linked together. So do you understand? P is not linked to R because Q is in between them. And if I was to draw another one, and I was to say, oh, my point P is actually up here, that'd mean it'd have to go P, Q, R, S. It has to be in a sequence, sort of anti-clockwise. Yeah. The other way around. Not usually. No, usually it's anti-clockwise. We'll find out. But the bottom, I actually say legally speaking, you could actually go that way because P is linked to Q, Q is linked to R, R is linked to S, so there shouldn't be anything wrong with it. So technically you should be able to go clockwise or anti-clockwise. Usually I find they always go anti-clockwise. Okay? Which one? Q, that is meant to be a Q. Okay? Shh. Now, what happens next, guys? Now, what happens next is this, guys, okay? Where is my last point gone? We don't know where the last point is. So this is point P is here. Point Q is here. I think R is going to be up here somewhere. Would you agree with that? R has to be in this region because Q has to link to R and R has to link to S. It can't be up here. Why is R not allowed up here? Because it wouldn't be PQRS then. It'd be PQSR, which is not allowed. Cameron. Yeah, go for it. So what Cameron said was correct, right? If you look at P going to S, it goes across 4, up 4. So that means Q going to R will be across 4, up 4. And that is your R value there. And if you were to link them all together, there goes your parallelogram. Yeah. So your R value is going to be 1, 2, 3, 4, 5, 6, 6 and 2 up. Is that right? We're going for QRS. Q is 2, 0. R is minus 4, 3. So that's Q to R, and S is minus 7, 2. Now, remember, S has to join to P. So if you're looking at that, I'd say you'd have two options in your mind. You could have an option up here somewhere, or an option down there. Now, which one is the proper option? It has to go P, Q, R, S. S has to link back to P. So if I put it here, it won't work out properly. So what we're doing this time around is we look at R to S. R to S is 1 down, 3 across. Therefore Q to R, or sorry, Q to P, 1 down, 3 across, and your point P is going to be minus 1, minus 1. And when you link them up together, you can observe that you have yourself a nice parallelogram. Okay. Now, next thing is central symmetry. Okay. I'll do 2 of these. They're very quick. Central symmetry, guys, is when you bring one point to another point and continue the same distance out the other side. As an example, central symmetry to the origin. If I had the point, what's that going to be? That I don't want 3, 3. It's too symmetric. 3, 2. If I had the point 3, 2, and I asked you to do central symmetry through 0, 0, central symmetry through the origin, where would you end up out the other side? So you go 2 down, 3 across, and you go 2 down, 3 across out the other side, and you end up at minus 3, minus 2. We're doing something very similar to that in question 7 and 8. In question 7, the image of 4, 3, which is going to be 4 across and 3 up, you have to find the image of this under central symmetry in the point minus 2, 5. So locate minus 2, 5, 2 across, and now I'm going to colour it in red. The red one is your focal point, and what you're doing is you're going across how many blocks? 1, 2, 3, 4, 6 across, and 2 up. So now go across another 6 and another 2, and then you find your image. And so what you can say there is it's going to be how many? That's 2, 4, 6, 7 across. So minus 7, and how many up? 7. Minus 7, 7. Is that alright? Yeah, question A. Okay. So in question A, what you're doing is the image of the point minus 4, 0. Minus 4, 0 is located here. The focal point, or what you're trying to get symmetry in, is 3, minus 1. So what you do is you count how many blocks you need to go down. You go down 1 across 7. Go down 1 across 7 again. Yeah, pretty sure. I just didn't line up the line perfectly this time. So that's it there. So count it across 2, 4, 10, and minus 2. Yeah.